Hello everyone, I hope everyone is doing great. So, I am Noob Gecko from a third world country and I'm currently a CSC student. So, I'm currently in second year, and this series that I'm going to make is about machine learning. I have a huge obsession about machine learning and I'm planning to be an ML engineer in the future. But as I said before, that I don't have a resources, so I had to learn everything on my own. So I thought of why not document the whole process. And I have been nurturing all this stuff, machine learning stuff, for some times already. But before starting, like what I learned this week, as you already guessed it from the caption, what I already learned, I'm going to introduce you to the things that I already know. Now, as I said that I'm a CC student, so I have previous knowledge about Python concepts, like how to write code in Python, what is loop or conditional statement or functions and variables, and I also had some knowledge about metrics, like how to multiply a matrix or like how to calculate eigenvalues out of a matrices. So some basic knowledge about that before starting this machine learning series. But those were obviously not enough, as we all know that machine learning's foundation is totally based on math. And in order to get better in machine learning, I had to start by math, and the first topic that I choose is linear algebra. And for the past week I was learning linear algebra. So this is the thing that I learned so far in the past week. The first thing that I learned in linear algebra is matrix and vectors. Now these are quite important in terms of linear algebra. If you don't have much knowledge about matrix and vectors, then you cannot work with data or anything in machine learning. Well, I came across one thing, that in machine learning every data is represented in matrices or vectors. Like there are lots of other ways you can manage data, but most of the data is stored in matrix and vectors, and that is why it's very important to learn about matrix and vectors. And I started to did that. I actually learned what are matrices, what are vectors. I also found the difference between them. Then I also learned about matrix transformation. Now, as I said, that I had previous knowledge of linear algebra, like how to do multiplication of a matrix and etc stuff, but I could not visualize that transformation, like how a matrix multiply, or actually not multiply. I learned some just in this previous week that matrix are never multiplied, they just transform. Let's say I multiply a matrix A with another matrix B, and I get a matrix C. Now many people say that I multiplied the matrix A with B, but it's not a multiplication, it's just transformation. First we transform the vector with A, then with B, and ultimately we get C. Like if we transform sequentially, then we'll ultimately get C. So these were the things that I learned in the last week. And after that I also learn about symmetric and orthogonal and identity. Like these are the types of matrix, like what is a symmetric matrix, what is orthogonal or identity matrix, square matrix, etc stuff. But among them I found symmetric and orthogonal matrix very important in terms of machine learning, because it actually covers the part of decomposition and also SVD stuff. Like you need to have a solid knowledge about the symmetric and orthogonal matrices. So that's all I learned. And there was some function that I learned in NumPy, like some functions and some way to actually represent data in a graph using matplot library in Python, which I'm going to show in just a few seconds. But before that, let me show you something cool. As I mentioned, the eigen decomposition is really important. This is A is a symmetric matrix, and P is the matrix of eigenvectors of A, and D is the eigenvalues diagonal matrix, and P inverse obviously is the P inverse is the inverse matrix of this P, or the matrix of A's eigenvalue. So these are the stuff that I learned in the previous week. And most importantly, SVD matrix. This is very important because A is a symmetric matrix and this equation only applies for symmetric matrix, but SVD applies for all kind of matrix. It does not know any limits, because we're not gonna get matrix in the symmetric way every time. We're gonna come across some matrix such as like 1 2 3 4 5 6. Obviously this is not a symmetric matrix, but if we want to decomposition this matrix in 3 terms, then we need to know the SVD or how to do this SVD part. Now moving on to the function of numpy and matplotlib, like there are some interesting things that I learned. For example, here, like how to import a library, then what the line spans means. This is very important in order to plot a graph in the matplotlib library using. So these are the plot that I did with some data, like with some equation, like dr and dp are 2 equations, and I wanted to find where they meet with each other. For example, like this isn't just robber and police example, where the robber is trying to escape from the police, but the police is chasing him down. Now this graph shows in which time and which distance the police catches the robber, and this is a really fun example of plotting or using matplotlib. And after that, there are lots of other fun stuff that I did with these functions, which is many, because I was just tweaking and making a lot of example by myself in order to learn that. Like these are the vectors arrow. Like if let's say I want to represent a vector which value is 1 by 3, then this red arrow would be that vector. Like I just implemented the vector using some function from matplotlib. I just plotted some vector. These were not such a great something very great or higher level knowledge, but it really increased someone's knowledge just by tweaking it. And after that, more example of that vector. And I think the most important part here that I learned is the using of function of how to find using the function of eigenvalues and determination of an array. Like this is an array, or you can call it a matrix, because it's an 3 by 3 matrix, and this function calculates the determination of this matrix, and this is the eigenvalue. This calculate the eigenvalues and eigenvectors of that matrix. So these are the function that is automatically comes with this numpy library, and I learned the use of this function. After that, we also have some example of this function. Like here I tried to do the inverse of the matrix of eigenvalue matrix. Like I wanted to prove the theorem of this here. As we can see, the P represent the vector of A's eigenvalue, where EV is the vector of eigenvalues, and P inverse is the inverse of the vector, inverse of the matrix with the eigenvalues of A, and I did the inverse here. Now according to this equation, if we dot product 3 of these together, we are gonna get A matrix, which is this matrix. And now as you can see that after multiplying 3 of them together, I get 1 2 3 4, the same matrix like this. This just proves the theorem. Now obviously you don't have to understand like the whole process of how to multiply one matrix with another. We just need to know that there exists a function which can do that for us. Like we just need to know the theory. Then this thing here, what happened here, yeah, this is another example of the symmetric matrix. Here as you can see that diagonals are random, but the entry here and here are same, are in the corners are same. So this is a symmetric matrix, and it also holds this equation. So these are the example that I tweak up and have fun with, just to get better understanding. And the most important thing that I learned in the previous week was the SVD. Now, as I say, is that the SVD method is very important, as it shows the eigen decomposition of and random matrix, a matrix which is not symmetric. So this is really important. Here I learned that U is the matrix of which is n by m. U is the matrix of eigenvalue of left a matrix of A. So this is really complicated to say, but let me show it by example. Let's say there is a matrix A. The left matrix would be A into A transpose. This would be the left matrix, and after I get this matrix A into A transpose, which is going to be an square matrix. If you guys don't know, this is going to be a square matrix, and I believe it is going to be a symmetric matrix as well, or orthogonal matrix, sorry. Then we are going to find the eigenvectors of this matrix, and that is where we are going to get our U from here, like this U. We're gonna get the U, and this summation sign is this same size matrix of A. It has the same dimension as A, but it's special kind of. It is going to have the eigenvalue in descending order. I'm repeating, descending order, and the rest of the entity will be zero. Field will be zero. So like these are the special properties of this SVD, and that's what I learned. Linear algebra is finished. I would not say finished, but I get the concept of how the things are working behind the scene. I just don't need to calculate everything by hands, like how to multiply matrices, like how they are subtracting from some entities from matrices. Like I don't need to dive in too deep. I just have the concept right now. I'm going to move to calculus to have better understanding in them. So I'm that kind of person who likes to actually learn from doing project, like learn from something, doing something, not by just watching some videos on YouTube or anything, but by doing something. So that is the way I learn.